Okay, everyone's found this spot. So day one of your exam is all of the graphing topics. So the first graphing topic is all those ABCD transformations. So do you remember the A can do a vertical stretch or a vertical compression, a B, a horizontal stretch compression, C shifts left or right horizontally, and D shifts up or down. Okay, the most important thing to remember with ABCD is this. How to develop coordinates. Do you remember that? You do need that memorized for your exam. A B compresses horizontally, so that's an X. Shifts left or right. A stretches your Y, and you can move up or down. Okay, so when I look at this is the original graph of f of x, and I have applied all of these things. So let's just point out what letters those are. So 2 would be an A. It's a multiplier in the front. And then this is a C, and this is a D. It will match this. Remember that? This is what it is. Remember that B always has to be factored out of that, right? That's another rule. If I ever ask you for the order of things occurring, what do you know about the order things specifically have to happen? If I have a stretch and a shift left, what would have to go first? The stretches before the shifts. And what does BEDMAS say? To do any stretch or compression, any multiply before an add or subtract, right? Stretches, reflections, compressions, those are all multipliers and dividers, have to happen before up-downs. Okay, so what I'm going to do is I'm going to list a few key points here. So can you get me those 4 coordinates that we're going to use? So -3, 1, 0, 1, 2, -2, and 3, 0. Okay, now we need to make a coordinate equation. Okay, so I don't have a B, so I have to do something with this C. What does this physically do? Do you remember that? Are you moving left or right? Right. Remember that one's the opposite. So I'm going to have to do that. I'm going to have to move right 3. Right? Whatever C is in your equation, you do the opposite because of the subtract. And then we need AY plus D. Did you think about that? AY plus D. Okay, so let's just run all the coordinates through. I'm going to do all of the x's here. So every x, I'm going to add 3. So 0, 3, 5, and 6. 0, 3, 5, and 6. Are we good with that? Okay, then I'm going to go do all my y's. So I'm going to double it and then subtract 1. So it ends up being 2 subtract 1 gets me back to 1. Okay, negative 2 times 2 is negative 4, subtract 1 is negative 5. 2 times 0, and then subtract 1. Okay, so I'm going to plot some of these points. So think visually, did you take your shape and did you pull it apart like strings? Did you pull it apart? Yeah, so it got bigger that way vertically, and then you shifted it right and down. Does it look like that stuff happened? Okay. Also with ABCD stuff, you're going to have to kind of work backwards, and I'm going to give you the 2 equations and you have to figure out what happened. So we're writing the g function as a transformation of the f. Okay, so we started with f. What did we do? So think first, bed mass, think multiplying and dividing. Did we do any compressing, stretching, or reflecting? Does anybody see anything physically that would have happened? It got squished in horizontally. So I can see a horizontal compression, which is a B value, right? So what do you think? When I look here to here, right? Those points are this far apart, and now they're this far apart. So they got squished in. Does anybody know how much it got compressed by? 2? Okay, ready? I'm going to draw the f function compressed. So this point here went from negative 2, it would have to go here. This x coordinate was at 4, so it would have to move to 2. And then how about I take that point right there, which is at 6, 2. Where do you move 6, 2 if you're squishing it in, horizontally compressing it? You would move it to 3, 2. Okay, so there's a compression, and now what happened? There's something else, because now it's way up here, right? So I'm going to compress it, and then it's going to have to all move up. How many points? 3. What letter does it move up 3 with? D. So g of x equals f of x with those things that happened. And that's always that format that you follow, right? So B went inside with the X. That stuff ringing a bell? Okay, I'm given this graph and it says to graph the inverse. Another way you might see inverse is written in this notation. Do you remember that notation? Graph the inverse, or I might say graph f of negative 1 of x. Or another way I could have asked it was reflect over that diagonal line, right? Those are 3 ways I could have even asked this question. Okay, so I need you to get the coordinates. I have 4 points on there that I'm going to take. So write the coordinates. Okay, what does inverse tell you to do? You take the coordinate and then you, remember that? You flip-flop x and y. That's all the inverse does. Changes the x, y. So you need to have 2, negative 3. You need to have 4, negative 1. 4, comma 1. And 2, comma 2. Now, the biggest thing is when you connect the dots and draw, there's an arrow on one end, right? So which end would the arrow be on and how do these connect? And there's the shape. If you're struggling with the arrow, you have to do that visual check. That's how it's reflecting. Does it look like it visually reflected over that diagonal? Okay, and obviously you'll get points deducted if you didn't put an arrow on the one end, because there was an arrow on that. Gotta be an arrow on that. Okay, reciprocal functions. Okay, so we take the y-coordinate and we do 1 over the y-coordinate. So I start with, where does y equal 0? That's what I always start with. Because what happens when you reciprocate that? What happens in math? Asymptote. So that's going to be right here. There's an asymptote. Okay. Invariant. What kind of number doesn't change when you reciprocate it? One, negative 1, right? If you reciprocate 1, it's still 1. So actually, this whole piece right here is flat at 1. It's going to actually stay flat at 1. This ending coordinate was at negative 1, so it's going to stay at negative 1. So all those points didn't even move. Okay, now I'm going to check out the points in this little section here. So on the graph, if it was getting closer and closer and closer to 0, what would your reciprocal do? it would shoot away, away, away from 0. Remember, the reciprocals are doing the opposite events. Closer to 0 means move away from 0. And same here on the bottom, that piece of the graph got closer and closer to 0, so you need to move away, away, away from 0. Okay? The only thing really to add to this is sometimes these y values, if you are going like that, then you also would have to create yourself a horizontal asymptote. This one did not have that because there was no pattern where you were moving closer and closer to that line. So sometimes you might have to have an asymptote there as well. But you have to analyze that. Okay, absolute values. What are the rules? If you have an absolute, if it's a positive number, what would you do with it? You would leave it, right? What about if you absolute 0? What's the absolute value of 0? Still 0. What happens when you absolute a negative number? Now it changes, right? So negatives reflect. Okay, so this graph, I actually have 2 transformations. So I have an absolute and a down one. Do you want me to absolute and then go down, or do you want me to go down and then absolute? What do you think? What do you think about the order? What should I do and then what should I do?
Absolute first.
Absolute and then down one. If you would have seen this, if I had that, what changes? The order changes there. Do you see that? This would say down and then absolute because it's in the brackets. Okay, so you have to pay attention to the order. Right? This says absolute it and then move it down, and this says down and then absolute it. So that's what the difference of that would be. Okay, so if you're a person that likes point to point to point, that is fine, but I'm going to suggest let's just kind of draw this. So I'm going to lightly draw with my pencil an absolute, and then after we'll draw it down. So if this is an absolute, then this portion of the graph would reflect, right? That negative would then be reflected upward. And then this would actually just stay there, right? So it's kind of like I have 2 hills going on. So that's the absolute. So you're done that. And now take that and move it down. And that's your final graph. So I absoluted it, and then I shifted down. Okay. Identify the x-intercept of this graph. When you have an x-intercept, right, it's on the axis, so therefore, if you're on the axis, the y has to be a 0. Okay, how do you solve something like that? What would be your first algebraic steps? I'm going to square both sides. Then you could either distribute or divide the two. There would be two methods here. Doesn't matter. I'll distribute. How about? Okay, I'm going to move the 10. So therefore, what is your x-intercept? Do we get -5? Okay, now let's graph this function. What kind of letters do you have? A, B, C, D, your transformation letters. Do you know how it would look generically?
A.
Right? Would that make sense generically with them all in there? So 2 is a B value. So my radical is going to get horizontally compressed. 5 is a C value. How will we physically move? Left? Those make sense? Okay, so when you graph radicals, you say, where do I put my starter point? Where is my starter point going to begin? My starter point is there. I moved it left 5, that was it. I didn't move it up or down, it just moved left. Do you remember how you should normally move in a radical? Do you remember this? If you move over 1, you should move up 1. Think about your square roots. What would be the next number you could square root? If you move over 4, you would move up 2, right? If you could move over 9, you should move up 3. This is the normal. But we're not normal. What are we going to do? We got to put the B in there somewhere. What does a B value do? X gets divided by B. So all those are going to get divided by 2. Okay, so you're going to move a half right 1 up. You're going to move 2 over, 2 up, and then you're going to move 4.5 over, 3 up. And then there's your radical. It's kind of like the sideways half parabola, right? It in turn does, yeah, because normally that's kind of your normal shape, right? So everything, once you shift the first one, they all follow that shift. Okay, state the domain and range of this radical function. What's the coordinates of the starting point? There's a C in here and a D. Where would you start? What coordinate?
8, 1.
Right 8, 1 up. So that would be an idea of your starter. Okay, now let's think about what that -3 does. What letter do you connect it with transformations? It's an A value, right? An A transformation. So are we affecting our overs or our ups? Every time we move over, we're going to actually be moving down. That's kind of what it would look like, right? Because the A changes the Y's. Okay, once you see the negative in there, everyone knows that makes a reflection. An A reflects over the x-axis. Okay, so what is the domain? So what's the furthest left to how far right? So it looks like I can go from an 8 x value and then keep going forever. So from 8 to infinity. And how do you write the range? What's the lowest to the highest? So negative infinity all the way up to 1. So on exams, you would get a half deduction if you didn't write them in that proper order, right? Down to up. Okay, number 9, I probably should have told you that I would like a radical function here, so you have to kind of go backwards. Can you write a function if I give you the domain? Okay, so this, I have a starter point. That's my starter coordinate. So I already know the C and the D of it. but now I need to know which direction this is heading, because then we'll have to figure out if anything got reflected. So this says that X is going, and we're going left or right? I'm headed left, because you're less than. And this says you're greater than, so you're headed up. So that's what my radical looks like. It's headed left up. Is that normal, or did something reflect? It looks like a reflect. So now you have to decide what kind of reflect was it. Are you going to be on your B or A or B reflected? What kind of reflection is that? It's a B. You have to factor out, if you have any B, it has to get factored out. Hint, hint. Somewhere on the exam, I did something like that, right? You have to factor B out. And then I need to move, how do I move left 2? I would actually need to write a +2. And I move up 3. There you go. Okay, rational functions. Okay, I'm going to factor this and see what happens. Can you try to factor the bottom there? Do you get something that cancels now? Okay, so we have to analyze what happened. There's 2 X values I cannot be at. I can never have X be a 4 or a -1. Do you see that on the bottom? So those values are not permitted. Non-permissible values. I can't have X. I can't have a 4 or a -1. Okay, what happened with the cancel? What does that create graphically? Do you remember that? It's a hole when it cancels. And if it doesn't cancel, it's going to be a vertical asymptote. Okay, now we need to analyze the horizontal asymptote. Degrees. Are they the same? Do you have higher on the top, higher on the bottom? Higher on the bottom. What does that do for a number if your bottom gets bigger, bigger, bigger on a fraction? 1/10 and then 1/100 and then 1/1000. What's actually happening to your number?
Closer to 0.
Closer to 0. So that's the rules. So I'm going to draw all that stuff in. I'm going to go -1 vertical asymptote. I'm going to go horizontal at 0. Okay, now I need to figure out what's actually happening as a shape. So I'm going to plug in. I'm going to kind of make a XY table here. So what are some good X values to plug in? How would I choose? You could pick anything for X, but what's the best thing to choose? A couple on that side, a couple on that side. So I'm going to plug in a 0 and a 1. And then on the other side of the asymptote, I'm going to plug in a -2 and a -3. Where am I actually plugging it in? To this. Okay, you ready? Plugging in a 0 creates 1/1. Plugging in a 1 on the bottom makes 1/2. If I plug a -2, it creates 1/-1, which is just -1. 1/-2 for that one. Okay, so can you see the shapes? Let's kind of figure this out. So I'm going to do the negatives. So -2, -1. -3, yep. -3, -1/2. And do you kind of remember your shapes just form around your asymptotes? So you're going to be going flat and left, and you're shooting down. Okay, now don't go too ahead of me on the right side. I'm going to plot those 2 points, 0, 1, 1/2. I can see the shape it's going to make. It's going to go flat right, but I also have to remember the hole. So 1, 2, 3, 4. Can you make sure you put an open hole when you make your shape? Okay. So rationals, analyze your asymptotes, make your shapes. Okay, exponentials and log functions. Okay, so this is a log function. So let's create some points with 5. So I'm using a base of 5, so I've got that information. Okay, so when I think about this as a coordinate, it's a log coordinate. So how do we always write log coordinates? Remember, it's the opposite of an exponential. Okay, so that's the basics of a log. Think exponentially and then flip them. That's a log. Now, what do we got to do? We're going to take those coordinates as our basic shape and move them. What does this move it physically? Right 1. Everything's going to get moved right 1. So all the points, I just need to make sure I move them right. Do you remember the basic shape of a log? There's an asymptote, right? Normally your asymptote's at 0, but we shifted everything right. So where's our asymptote going to be? Our asymptote is along the 1. So a basic log is usually x equals 0 as a asymptote, and a basic log usually has that coordinate 1, 0. Okay, exponential. Okay, so let's create some points with the base of 2. So the base is 2. So using a base of 2, I use those 3 things as my points. So this time exponentially is, if you input a 0, you get a 1. If you input a 2, you get a 2. Or if you input a 1, you get a 2. That's a basic exponential growth curve. Okay, what happens here? We got 2 transformations we got to deal with. This would be A, so it's going to reflect downward, and up 2, because that's a D. Reflecting and up. Okay, so we're going to get 3 new coordinates to graph. Nothing has changed with the x's. Okay, -1 plus 2 is 1. -2 plus 2 is 0. -1/2 plus 2 is 1.5. Okay, it might help you before you start to draw an asymptote. So if our asymptote was flat at 0, we shifted it up 2. We know we're going to have an asymptote there, up at 2. Does it look like our points will work with that asymptote? reflected. Yep, do you see that reflected shape? You gotta visualize that shape, basic shape, reflected, and then it got moved up after. Can you visualize that in your head, a reflection? Okay. Might just get this done. What do you, yeah. Okay, we have to figure out the equation of this. Okay, so if I graph 2 to the x, that would be that it's growing, it's doubling every time. So I already know I'm not that one, right? This one reflects downward. That's a reflection, right? Like that. So I know it's not that one. Okay, does it make sense? If x equals 1, you're at a half. If x equals 2, you're at a quarter. So here the thing to know is now on the exponential, if your base is a half, think about your population becoming half of it next year, half of it next year, half of it next year. You're decreasing, right? Exponential growth or exponential decay. You're getting smaller and smaller and smaller and smaller. Okay. Next, we have a trig curve. So the cos function, can you draw me basic cos? Cos starts at a max, right? Remember that? So now I'm going to put the 10 in place, which is a vertical stretch. So when I vertically stretch it, it's now got a max of 10 and a low of negative 10. Do you remember this equation? You're going to probably want to memorize that. 2 pi over b. It's the same as a horizontal compression. The x gets divided by b. 2 pi over pi divided by 2. That ends up flipping, so your period equals 4. So that means the end of this a cycle, a complete cycle, has an x value of 4. Okay, that helps you with other x coordinates. This is 1, 2, 3, and 4 now. Okay, on your final graph, you're going to have to shift. And my transformation is I'm going to move everything right 2. Okay, so 1, 2. So this was the starter, but now it's over there. At 3, I'm back to the middle. At 4, I'm at a low. At 5, I'm back to a middle. At 6, I'm at a top. And this tells me to graph it over a domain, so I'm supposed to stop at 6. But I have to kind of work backwards as well. So then from 1, at 1, we're going to go back to a midline. I kind of just did that point, and then I did everything else with it. Okay, I know there's 3 minutes till the bell rings, but I'm just finishing this. You can, if you need it your time, you can pack up and stuff, but I'm just recording, so I want to finish this. Okay, I have a max. And a min. So my D is my midline. So I just say what's right in between 100 and 300. 200 is my midline. My A is how much do I stretch? So from 200, I need to stretch up 100 and down 100. My period, from 5 to 15, I went 10, but I have to double that because that on my graph is only a half of a cycle. So 2 pi over b equals 20. So I use that to get a b value. So no matter if you're a sine or a cos curve, all of those are the same. Your C's are just different because you have to figure out which is a cos starter and which is a sine starter. So this top point can be a cos starter. So I can go subtract 5 on the cos. But I don't have a sine starter. I have to be in the middle, heading upward. So you have to either figure out what's the x-coordinate here or here. So how am I alternating? I'm going like 5, 10, 15, 20, or this is actually 0. So you actually don't need anything in there because you could have started sine at 0. Or you could have put minus 20.